So the first thing we're going to talk about is the zero product property. This is a property that you guys probably know, maybe you haven't really explicitly have written out. But essentially what it says is that if I know two things that are multiplied together are equal to 0, then either the first thing is equal to 0 or the second thing is equal to 0. And we use it a lot when we're factoring because it allows us to solve for x once we have all of our individual factors. So in this question, we have something that's already been factored. We have something that would result in x minus 3 times 2x plus 5 is equal to 0. And now I can use the zero product property to set each part equal to 0 to solve for x. So set the first factor, x minus 3 equal to 0. Pretty easy to solve that guy. I add 3 to both sides and I get the result that x is equal to 3. Now I can do the same thing with my other factor. 2x plus 5 is equal to 0. The problem solving process is a little bit more complicated, but it's not super difficult. I would subtract 5 from both sides. I'd get 2x is equal to negative 5. Then I would divide both sides by 2, giving my result of x is equal to negative 5 halves. Now, this section is really going to focus on a lot of different ways to solve quadratics. A quadratic is something that has x squared or y squared, something to the second power in it. So this is the first 4 minutes called simple factoring. It's not an ideal term for that because, I mean, factoring isn't the most simplest thing in the world, but of the methods that we're going to see, this process is definitely the least involved. And so in order to do simple factoring, what we have to do is we have to have 0 on one side of the equation. So if I'm going to try and factor this equation that I have, x squared plus 5x is equal to negative 6, then I add 6 to both sides, and I get 0 on the other side. So eventually when I get done with the factoring, I can use the zero product property and solve. Now to factor in the simplest form, what I do is I look at the last term, the term that doesn't have an x in it, and I look at my middle term, the term that has an x but not x squared. And I want to find two numbers that multiply to get me the last number, in this case 6, and add to get me the middle number, in this case 5. And it's usually easiest to kind of look at the multiply part of the equation because there's only so many things, or at least so many nice things, that can multiply to 6. So when I think about this problem, I think, okay, what multiplies to 6? Well, 1 times 6 does, but that doesn't add to 5. 2 times 3 gets me 6, and 2 plus 3 gets me 5. And so I've kind of solved the problem. I've guessed and checked and figured out what two numbers multiply to get me 6, add to get me 5. And so then I just rewrite my thing in factored form. My factored form will be a parentheses. It'll be, the fancy name's a binomial, but it'll be x plus my first number, which is 2, and x plus my second number, which is 3. So x plus 2 times x plus 3. Order doesn't really matter with factoring. So you could also write x plus 3 times x plus 2 is equal to 0, and that's perfectly fine. Well, now using the strategy that we talked about on the previous slide, we set both parts equal to 0 and solve. In this case, it's a one-step process, so I didn't really write it out explicitly, but I would subtract 2 from both sides. I get x equals negative 2. And I would subtract 3 from both sides and get x is equal to negative 3. Now, checking your answers is a very valuable thing throughout this course, and if you wanted to, you certainly could in this case. You would take those numbers, plug it back into the original equation, and then if you follow order of operations, you should get a negative 6 on the left side and a negative 6 on the right side, and that should work for both of these answers. If they don't, you might have made a mistake, maybe pick the wrong things when you're factoring. Definitely worth looking into, especially as we start to get into more difficult examples. Okay, now a more involved process is factor by grouping, and although it does have a lot more steps, it always works when we're factoring, where the previous method, the simple factoring, only works if, we see this equation up top, if there is no a. So if we see something like this equation, 4x squared minus 13x plus 3, I can't just use simple factoring on it because I have something in front of my x squared. In particular, I have 4. So I'm going to use this method of factor by grouping. My first step is I multiply the first term and the last term. So I multiply the 4 by the 3. And I'm going to kind of organize my information over here. So 4 times 3 is 12. I'm going to make an x. You don't have to make an x. I just Found that helpful when I've been teaching this course to organize my information. So I'm going to put the 12 on the top part of my x. And then I'm going to put that middle term of my equation, the negative 13, I'm going to put that on the bottom of my x. And now I play the same game that I played on the previous slide. I want to find two things that multiply to get me 12 and add to get me negative 13. Well, I've obviously done this problem before, but that might take you some time. Eventually, hopefully, you'll be able to guess, well, negative 12 times negative 1 gets me 12, and negative 12 plus negative 1 gets me negative 13. Now, what I'm going to do is I'm going to rewrite my equation with this new information. In particular, I'm not going to change the first term at all. I'm not going to change the last term at all. I still have my 4x squared. I still have my 3. I'm going to change my middle term. So I broke up my middle term and I took that negative 12 from that big X on the top right. And I took the negative 1 from that as well. And so I'm going to rewrite my equation as 4x squared minus 12x minus 1x plus 3 is equal to 0. Now, where the title comes from, the factor by grouping, is at this point I'm going to group the first two terms and I'm going to group the last two terms. And after I've done that, my goal is to now figure out what fits into both of those first two terms, only those first two terms for starters. So I look at that, I have 4x squared and I have negative 12x. Well, the biggest number, and we need to find the biggest number that fits into both of those is 4, and x fits into both of those terms. So what I would do is I say, okay, well, 4x fits into both of those terms. I'm going to divide both terms by 4x. And so that first part now becomes 4x times x minus 3. 4x squared divided by 4x gets you x. And negative 12x divided by 4x gets you negative 3. And now I'm going to repeat the process for the next group, that negative 1x plus 3. Now you might be thinking, well, there's no x's in both terms, so I can't factor out an x, and there's really no number bigger than 1 that fits into both of them, so I can't really do anything with that. But one cool feature of a factor by grouping is that if you're doing everything correctly, then your two factors in this step that we're on right now need to match. And so my first factor, I have x minus 3. I want to make it so I have x minus 3 in my second, and I currently don't have that. So to resolve that, I'm going to pull out a negative 1 out of both terms. And by pulling out, and I should have said this in the first thing, I'm dividing both terms by negative 1. So I go ahead and do that, and I put the negative 1 in front, and then negative 1x divided by negative 1 gets me x. 3 divided by negative 1 gets me negative 3. And now notice here I have matching. That's the goal. If you're not matching in this step, you did something wrong. Maybe you didn't pull out a big enough factor above, or maybe you needed to pull out a negative, or maybe you didn't pick the correct factors up in that big X that we had, the negative 12 and the negative 1. So that's a nice little checkpoint. And so since they are matching, we did it correct, or we probably did it correct. And so I look at the two terms in front of my groups, so the 4x and the negative 1, and that becomes one of my factors. And then my other factor is the thing that matched up, my pair. I have my pair of x minus 3's, and so that's going to be my second factor. And now I have my factored form, 4x minus 1 times x minus 3. And if I wanted to check with the factoring at this point, I could multiply that back. I would get all the way back to the start of my problem. So now I'm going to use, again, the zero product property to solve. I'll set the first factor equal to 0 and the second factor equal to 0. Solve the first one using some basic algebra. I add 1 to both sides. I get 4x is equal to 1. Divide 4 from both sides. I get x is equal to 1/4. And then the next equation is a one-step problem. I just add 3 to both sides and I get x equals 3. Now, well, the title of this section is Quadratic Equations or Quadratic Functions. So if you see a question like this, you might think, well, okay, now I do have an x squared, but I have an x cubed. I have something bigger. And this is called a cubic. And so to kind of deal with that, we're going to use a similar idea, similar concept. We're going to move everything to one side. We're going to get a 0 on the other side of the equation. Now, ideally, it would be nice to make this or turn this into a quadratic, because then we could use the strategies we've seen on the last two slides. Well, we can actually do just that by taking out the greatest common factor, which in this case is x. I can pull an x out of all three terms. So I would divide each term by x. Well, x cubed divided by x becomes x squared. Negative 2x squared divided by x gets me 2x. And negative 3x squared divided by x gets me negative 3. And now I have a quadratic inside of the parentheses. So I'm still going to solve for x eventually, but now I'm just going to solve for my x squared minus 2x minus 3. Well, I guess I solve for it immediately in this question. So I know x is equal to 0 is still one answer. And so to find my other x's, I'm going to take that stuff inside the parentheses, and then I'm going to factor it again. And this one is kind of a nice simple factoring question. I'm going to look for two things that multiply to get me negative 3 and add to get me negative 2. Well, negative 3 times 1 gets me negative 3. Negative 3 plus 1 gets me negative 2. Those are my two factors. I set them each equal to 0 and solve. So I get the result x equals 3 and x equals negative 1. So I get 3 answers. Now we're going to kind of pivot a bit, and we're going to go outside the world of factoring. And factoring is very, very valuable. We're going to see that time and time and time again throughout this course. So if you aren't comfortable with any of those methods I just showed, I'd recommend kind of reviewing them, doing the practice problems now, so you feel confident with them. But instead, we're going to kind of focus on something else. And so in order to build up to those concepts, we're going to talk about just the idea of square roots. So if I have this equation right here, x squared is equal to 4. In order to solve it, I need to undo the square. Well, when we're undoing the square, what we do in mathematics is we square root both sides. So we will get x is equal to 2. Square root of 4 is 2. But that's not the only answer that works. There's another number that if I multiply it by itself, I would get 4, and that number is negative 2. So to account for this, when we're solving equations with squares, if we take the square root of both sides, what we need to do is we need to say, okay, I can have a positive value, or I can have a negative value. So to kind of see that in practice, I skipped ahead a little bit on the right side here. I'm going to solve this equation. If I'm going to solve a square root and I don't have a trinomial, or I don't have extra x's flying around, I'm going to try and get everything to one side and leave the x squared on the other side. So in this case, I'm adding 50 to both sides. I'm going to divide both sides by 5. I'll get x squared is equal to 10. Well, now I'm going to use what I learned from the previous problem. I'm going to square root both sides, but I need to make sure to account for the fact that I can have a positive answer or I can have a negative answer. So I'm going to put a plus or minus in front of my square root. And you should be doing that anytime you're square rooting in this course, is you should think, if I'm solving, I need to put a plus or minus in front of my x. Now, if that was a nice number, if that was a square root of 16, I would find the actual answer. But it's square root of 10. We could get an answer in your calculator. It's going to be some weird heavy rounding thing. I honestly prefer you just leave that as x equals plus or minus 10. Now, building into this concept of completing the square. Completing the square is a very, very, very difficult concept. It's something that, over my years of teaching, always gets complaints. It's something that if you were learning it in high school, you'd probably spend a full week on it. We don't really have a full week. So all that's being said is, don't worry if you watch this slide for the first time and say nothing really makes sense. Watch it again. Watch it the third time. Honestly, look up other things online, because this is such a notorious concept that there's a lot of really good resources out there. I'm going to show you a method that I've had the most success with. So I have this equation here, x squared plus 4x minus 3. I could try and factor it. Spoiler alert, that is not going to work in this case. So instead I'm going to try a different method, and that method is completing the square. So what we saw in the last slide is that Well, if I'm able to kind of isolate my square root, then I have a pretty nice problem to solve. I just square root both sides, put a plus or minus in front of it, and then get x by itself afterwards. So that's what I want to do. I want to have x plus something on one side of my equation and maybe some other stuff on the other side of the equation. So my first step when completing the square is to get all the x's on one side and get all of the numbers on the other side. So I'm going to add 3 to both sides. Now, what I've done, and this is actually not mathematical at all, it's just a placeholder for me to be aware of. What I'm going to do now is once I've added the 3 to the other side, I'm going to put blanks on both sides because eventually I'm going to put something in that blank spot. Now, the why of it is that if you are doing something like x plus d squared, let's look at the top right of the slide again. If you're looking at something like x plus d squared and you multiply that out, you FOILed it out, you would get a term that has no x's in it. And so that's currently missing on the left side of my equation. So I'm going to kind of do something to compensate for that. And that something is going to be built off of 3 pieces of information. The first thing is my b. Well, on the previous slides, we've seen that generally a quadratic form has ax squared plus bx plus c. So your b term is always what's in front of your x. So in this case, I have 4x. Well, my b is 4. My next piece of information I'm going to find is b over 2. That's 2. I just divide my b by 2. Nothing really fancy there. Finally, third piece of information is I'm going to square my b over 2. So my b over 2 is equal to 2, so b over 2 squared in this case is equal to 4. So my first step in actually when I go back to my equation is going to be, I'm going to take that third piece of information and I'm going to put it in both blank spots. So I'm going to put a 4 on the left side, I'm going to put a 4 on the right side. Kind of following the golden rule of algebra, if I put something on one side, I put it on the other. Now my next step is, and this is almost like a magical step if you haven't seen completing the square, is I'm going to factor my left side immediately. And if you wanted to factor it kind of as we've done on previous slides, that's perfectly fine. Do that. That'll be a little bit more work, but at least it might make a little bit more sense in your head. But their shortcut is we know the left side's going to factor to x plus whatever your b over 2 is. And that's always going to be the case. So we're going to use the third piece of information by putting it on both sides of the equation. And we're going to use the second piece of information by putting it inside our parentheses. So I get x plus 2 squared is equal to 7. Well, you might be curious where the 7's coming from because there's so many things going on right now. Well, the 7 comes from 3 plus 4. So the right side is 3 plus 4 is equal to 7. The left side is x plus whatever my b over 2 is. Parentheses squared. And now, well, we haven't solved the equation, but now we're done with the completing the square. So hopefully we're done with the scary part. At this point, I just need to solve for x. So I do that by, well, I need to get rid of that square, so I'm going to square root both sides. I need to make sure that since I'm square rooting both sides, I put a plus or minus in front of my 7. And then to solve for my x, I'm going to subtract 2 from both sides. Now you might think, okay, well, if you subtract 2 from both sides, maybe you should put it after the square root of 7. That's fine if you want to. A lot of times when that happens, people kind of draw that square root a little bit longer than they should, and the negative 2 kind of gets absorbed. So it's a good idea to kind of just put that negative 2 in front, or if it's whatever you get moved to the other side, you put in front of that plus or minus for the square root. And that's your answer. And again, like I talked about in the last slide, if that square root of 7 is a nice number, definitely find it. Definitely do negative 2 plus that number, negative 2 minus that number, because that makes more sense. If it's not a nice square root like we see here with the square root of 7, stop. That's your answer. Now, if you want to rewatch that, that's great. I'm going to actually do another example, kind of hammer this idea home. So if you want to wait to rewatch this video or rewatch this slide, because we're going to see it again on the next slide, I'd say that's a good idea. If you really want to kind of get this idea or this slide down first, that's perfectly fine as well. So here's the second example. In this case, well, I can go ahead and skip the first step. I already have all my x's on one side. I have my numbers on the other side. So I'm just going to go straight into putting in those blanks. Now I'm going to identify those 3 pieces of information. My b is negative 2. My b over 2 is negative 1. And my b over 2 squared, negative 1 times negative 1 gets you a positive 1. So I'm going to put positive 1 into both of my blanks. And then I'm going to do this step that this is, by the name, this is the completing the square step. So I'm going to form a parentheses on the left side of my equation. It's going to be x plus negative 1 squared, which is x minus 1 squared. Those are the same thing. And then 3 plus 1 on the right side gets me 4. So I've completed the square. Now I just fall back to solving a square root equation. I'm going to square root both sides, put a plus or minus in front of that square root of 4. Well, the square root of 4 is 2, so I'm actually going to get that whole number. I'm not going to say it's the square root of 7. I don't really know where it is, what it is, or the square root of 10. I'm going to actually find the value. And now I'm going to add the 1 over. Get x is equal to 1 plus or minus 2. Well, that plus or minus 2 isn't some sort of Greek symbol. That's completely meaningless. It means, well, hopefully what you think it means. It means that I actually have two solutions. One of them is 1 plus 2. And one of them is 1 minus 2. So since we have nice whole numbers, we might as well just go ahead and figure out what those two answers are. 1 plus 2 is 3. 1 minus 2 is negative 1. So x equals 3, x equals negative 1. Now, if you wanted to go back and check your answers, actually a pretty easy problem to do this with. Good idea. There's a lot of places along the way that you can kind of make a mistake. So plug it back in, very basic algebra, and you will get, you should get 3 is equal to 3 for both of those values. And finally, the final method that we're going to talk about to solve quadratics is the quadratic formula. Now, I may have misspoken earlier with factor by grouping, but one of the cool things about the quadratic formula and completing the square is that it works for any quadratic. And simple factoring is very quick and it's nice when it works, and factor by grouping is valuable and also fairly quick when it works, but they only work if your question can factor. The quadratic formula and completing the square do not need that requirement. You will be able to solve any equation in that form. And this one's kind of nice because it's a little bit more computation heavy, which means you're going to plug in some values and do order of operations, but it's still valuable and very quick. And if you go into like anything with computers, it's nice to be able to use a formula and plug in a lot of values instead of having to kind of struggle with the concepts of what completing the square actually means in each individual step. So a lot of students really like this, but that's not to mean that completing the square isn't valuable. Honestly, if I had you guys only learn one of them, I would say make sure you're really good with completing the square. That being said, this is valuable. That was long-winded. Anyways, so I mentioned, or at least I've displayed on a couple of slides and mentioned offhandedly, but I should explicitly say it. This is the definition of a quadratic equation. I need to have an ax squared plus bx plus c is equal to 0. Otherwise, it's not really a quadratic equation. And yes, when we're using completing the square, we move to the other side. If we're using the move c to the other side, if we're using quadratic formula, we need to make sure we have everything on the same side of the equation. So if I'm asked to use the quadratic formula in this question, I have 2x squared plus 16x is equal to negative 5. Well, I can't do that because I don't have a 0 on one side and I don't have everything to the other side. So in order to use the quadratic formula, my first step is to add 5 to both sides. And now I have 2x squared plus 16x plus 5 is equal to 0. And this next step is a little bit involved, but all I'm really doing is I'm taking that formula that I have boxed and I'm putting everything in the correct spot. So I'm going to put in 2 everywhere I have an A, I'm going to put in 16 everywhere I have a B, and I'm going to put in 5 everywhere I have a C. And so what that will look like is this. And then from there on out, if I'm trying to solve for x, I'm just going to do order of operations. So I'm going to square my 16, and I'm going to multiply my 5 times 2 times, or 4 times 2 times 5. So I have a square root of 256 minus 40, all square rooted, and then negative 16 plus or minus all over 4. Well, I'm going to subtract those things in the square root. I guess not in that step, in this step. So I subtract things under the square root, and now I'm going to stop because, well, square root of 216 isn't a really nice number. Again, if it was, let's say that was the square root of 16, well, yeah, you should find what that is. That's 4. You should do the plus and the minus thing that we saw with completing the square. You should go through the last couple of steps to get the actual solutions, but if you can't do that, that's perfectly fine. Don't round, don't get me weird answers unless you're doing an applied problem. Just stop there and that's your answer. But that's the process. It's pretty much, I think my high school teacher called it plugging and chugging. All you're doing is plugging in values into the quadratic formula, and then you're following order of operations until you either get a solid answer or you get everything simplified as possible, and you can't take the square root of that number, and so you'd stop like we saw here.